This is a tutorial on multiplying and dividing rational expressions. When we multiply rational expressions, we multiply them just like any other fraction. If I wanted to multiply 3/4 by 1/2, I would multiply across. So I would multiply my two numerators, so 3 times 1, and then I would multiply my denominators, so 4 times 2. We'd end up with 3/8. Well, the same thing happens when we have variables or these rational expressions. We multiply our numerators and we multiply our denominators. So if I have 4x over 2x squared and I wanted to multiply that by 3x squared over 2, I simply multiply across. I multiply 4x by 3x squared, and then I multiply 2x squared by 2. Now, 4 times 3 is 12, and x times x squared is x cubed. 2 times x squared times 2, well, 2 times 2 is 4, and x squared is just x squared. So my new rational expression then is 12x cubed over 4x squared. Now I can simplify this because this 12 is the same as 4 times 3, and my x cubed is the same as x times x times x. In my denominator I have a 4, and then I have an x times x for my x squared. My 4 will cancel, this x will cancel, and this x will cancel, and we'll be left with just 3x. Let's try this again. Here we have 10xy squared over 4 times 2 over 5xy. Now we have two variables in this expression, but that doesn't matter. Again, we're just going to multiply across. So my numerators are going to get multiplied together and my denominators are going to get multiplied together. If I do that, I'll have 10 times 2 times x times y squared. My denominator will be 4 times 5 times x times y. Now 10 times 2 is 20, and then we have an xy squared. My denominator, 4 times 5 is 20, and then I have an xy. So this is 20 times x times y times y. In the denominator I have a 20, and I have an x and a y. My 20s are going to cancel. My x's are going to cancel, and one of my y's is going to cancel. So after we do our multiplication, this will simplify down to just being y. Now let's see what happens when we multiply a rational expression and a polynomial. Here we have 2 over 9x minus 9, and we're multiplying it by x squared plus 3x minus 4. Now you can think of this x squared plus 3x minus 4 as that quadratic over 1, because that doesn't change the value of that quadratic. And then when we wanted to multiply this, we would multiply this across. However, when you multiply rational expressions and you have polynomials in both the denominator and the numerator, it's usually easier to factor them first if possible. So this is going to be 2 times, now my factors of x squared plus 3x minus 4 would be x plus 4 and x minus 1. Now in my denominator of my rational expression, I can take out a greatest common factor of 9, and I'll have 9 times x minus 1. Now don't forget this x plus 4 and x minus 1 is over 1. And now we're going to multiply these together. We're going to multiply across. That doesn't change much. This will just be 2 times x plus 4 times x minus 1 over 9 times 1 is still 9 and x minus 1. Now looking at this, the reason why we factored these to begin with is because it makes it very easy to see if terms will cancel out. Here I have an x minus 1 in the numerator and an x minus 1 in the denominator. So these are going to cancel. So I'm left with 2/9 times x plus 4. So my solution then would be 2x plus 8 over 9. So whenever you multiply a rational expression by a polynomial, you can just put the polynomial over 1, so you can multiply it like a fraction. But remember, try factoring the polynomials first, because it'll help you find common factors in both the numerator and the denominator. So what happens if we want to multiply rational expressions that are made up of multiple polynomials? Well, again, we would multiply across. We'd multiply our numerators together, and then we'd multiply our denominators together. But again, this is usually easier if you factor or simplify your expressions first. So this x squared plus x minus 6, well, that's going to factor into an x plus 3 times an x minus 2. And it's still over x, and we're going to multiply it by this x squared plus x. Well, I can take out a greatest common factor in that numerator of x, and I'll be left with x plus 1. Now my denominator, this x squared plus 2x minus 8, that will factor into an x plus 4 and an x minus 2. Now we multiply these together, we multiply across, so I'm going to end up with x plus 3 times x minus 2 times x plus 1. And then in my denominator, I'll have an x times an x plus 4 times an x minus 2. Now these x's will cancel. This x minus 2 will cancel. And we're left with x plus 3 times x plus 1 over x plus 4. So this would be our solution if we were to multiply these two rational expressions together. Now you could factor or FOIL out this numerator. You'd end up with an x squared plus 4x plus 3, and that's still over x plus 4. Either way is acceptable. Now the last thing we have to talk about are dividing rational expressions. Well, when we divided fractions, say I wanted to divide 3/4 by 1/2, the simplest way to do this was to multiply by the reciprocal. So we would have turned this 3/4 and 1/2 into a 3/4 times 2 over 1. We would just flip this second fraction. And then this would be a multiplication problem from then on out. 3 times 2 is 6, and 4 times 1 is 4. We'd end up with 3/2. Well, the same thing happens when we're dividing rational expressions. We just take our second expression and we multiply by its reciprocal. So this will be x squared minus x minus 2 over 2x squared, and we're going to multiply that by x cubed minus x squared over x squared plus 4x plus 3. So now again we have a multiplication problem. If we were to complete this, it's usually better to factor these quadratics and polynomials. This first one, this x squared minus x minus 2, well, that will factor into an x minus 2 and an x plus 1. That's still over 2x squared. My x cubed minus x squared has a greatest common factor of x squared. So we'd have x squared times x minus 1. My denominator of this second rational expression, this x squared plus 4x plus 3, that factors into an x plus 3 and an x plus 1. Now when we multiply these, we multiply our numerators and then we multiply our denominators. My numerator will be an x squared times x minus 2 times x plus 1 times x minus 1. That's over 2x squared times x plus 3 times x plus 1. Now here we have an x squared and an x squared, so those will cancel. We also have an x plus 1 and an x plus 1. So our solution then would be x minus 2 times x minus 1 over 2 times x plus 3. Now if you want, you can FOIL out the numerator and distribute in the 2 in the denominator. If you do that, you'll end up with x squared minus 3x plus 2 all over 2x plus 6. And that completes the tutorial on multiplying and dividing rational expressions.